Hello guys, welcome to my channel Tech Gigs, and today we will be going through AWS Lambda. This is a small introductory session of AWS Lambda before we start our practicals or hands-ons. So here in this slide, you'll see the objectives of this program. We will learn what is serverless, what is nanoservice, what is AWS Lambda, what are the benefits of AWS Lambda usage, how Lambda works, the Lambda architecture, and lastly, we will go through a small example of how we can build a serverless e-commerce using Lambda. So guys, let's understand what is serverless. So serverless computing, so from what it is to why it's considered disruptive to traditional cloud computing in the market is focus on your application and not the infrastructure. So in fact, serverless computing simply means that you, the developer, do not have to deal with the server. So for example, if you're a Java developer or PHP developer, in earlier days, you have to, for Java, probably you have to install Tomcat, you have to install VAS server. For PHP, probably you have to install HTTP server. So you don't have to deal with that now. A serverless computing platform like AWS Lambda, could be any other platforms, allows you to build your code and deploy it without ever needing to configure or managing an underlying. Don't think about the servers. It's AWS will provide it for you. You just need to build your code. So your unit of deployment is actually your code, not the container that basically will host the code or the server that runs the code, but simply the code itself. So from a productivity standpoint, they're definitely a gain. For example, as a developer, definitely don't need to think about the servers. You just concentrate on coding, which will be much more faster, right? And in terms of pricing, definitely the price is based on the usage and the execution time of the code, not the installation of the license of the server and all those things, right? So definitely a financial advantage is also there. So despite the name, it does not actually involve running code without servers. So what does it mean? It doesn't mean that you are actually running your code without a server. It has a server, right? We will go into that architectural part. So the name serverless computing is because the business or the person or the developer who actually owns the system, so does not have to purchase or rent or provision servers or the virtual machines for the backend code to run on. So that's exactly what they mean to say, right? So serverless code can be used in conjunction with the code written in traditional server style, such as microservices. So for example, if you are building a web application which is actually calling a microservice, so microservice can be deployed, okay, in Lambda, and similarly in another part there could be another code which is being executed completely separately, right? So here, as you see, this basically represents FAS. So what is FAS? FAS is function as a service. So probably microservice is a function, probably another code is a function, another piece of code that you have written is also a function, which are all deployed in AWS Lambda. So each piece of code works as a function, and you are actually, your client, or not you, actually the client that you've created will be calling each one of the functions, right? And function may be dependent on each other and may be interdependent on each other, or may not be dependent on each other. So alternatively, an application could be written that uses no provisioned servers at all, so being completely serverless. So which means that you can write a web application just deployed into the Lambda, right? That will internally provide you a Tomcat server on which your application will be deployed, right? But generally this actually doesn't happen. I mean, this is not a good practice. It's better to use FAS, that is, you write a piece of code which uses a function as a service, right? We'll discuss this in the nanoservice part, like how it works. So let's look into the architectural diagram over here. So here is a serverless execution model in a nutshell. So basically, if you see that the client actually is making a request to the serverless computing platform, now it could be an AWS Lambda, it could be a Google platform to execute a specific function. Okay, so serverless computing platform will first check to see if the function is running on any of its servers. So in the below that, see, there are a lot of servers are there. It could be for the Python, it could be for Node, it could be for Java, it could be for C hash, C sharp. So it could be like anything, right? So if the function isn't already running over there, then the platform loads the function from a data store. So the function data store means here for AWS it could be S3, right? It will load the function from the S3 and will start executing it. The platform then deploys the function to one of its server. So based on the technical part of the function, example, like if a function is written in Java, so then the JVM will be considered and probably will be deployed in a Tomcat server, right, which are basically pre-configured with an execution environment that can basically run the function. So at the end, it executes the function, captures the result, and returns the result back to the same client. Sometimes serverless computing, as I said, that is also called as a function as a service, because the granularity of the code that you build is a function. Function means normal method, right? Just a function for probably, let's say you are building a calculator, so it's just an addition of a function. Add method is a function, so simply a subtract method is a function, right? Each unit can be deployed into that serverless, and if you are building a calculator app, so each of the methods will be deployed in the Lambda, and basically each one of the method will be called as part of a separate function. So the platform executes your function on its own server and orchestrates the process between functional requests and function responses. So here we will be understanding the nanoservice architecture. So basically, three things really matter about serverless computing. It's the nanoservice architecture, infinite scalability, and the pricing model associated with that near infinite scalability. The term nanoservice is not an industry recognized term, but the idea is pretty simple. So each nanoservice should implement a single action of responsibility. So for example, let's say if you want to create a widget, the act of creation would be its own nanoservice. So creation will be one single nanoservice. If you want to retrieve that widget, so that retrieval method will be another nanoservice. And if you want to place an order for a widget, then basically that will be another nanoservice. A nanoservice is basically the smallest part that you can extract from monolithic applications. You understand, right? What is a monolithic applications that we built like 2 or 3, 4 years back before the microservice days. So you can split a monolithic into multiple microservices. But again, those microservices can also be split into multiple nanoservices. So let's look into a small example with the diagram that is shown over here. So basically, let's say the monolithic architecture basically will look. So here is a client and app.js. Let's say it is built in Node.js. So basically the user, you can retrieve the information of the user. You can log into the applications through a single method, which is part of a single class called app.js. And similarly, within the same class or the same JS file, you have the retrieval of the games through which you can play. So here all requests goes to a single Lambda function, which is app.js. Users and games have nothing to do with one another, but the application logic for users and games are in the same Lambda function. So let's understand the pros of this. What are the advantages? So here the greatest advantage that the monolithic had over nanoservices and microservices is basically the speed of deployment. With nanoservices and microservices, you have to deploy multiple copies of dependent node modules, right? And the library code that your functions share, which can be slow. But with monolithic, it's a single function deployment to all API endpoints. So deployment is pretty faster. So what are the disadvantages? Disadvantage is definitely a tight coupling. In this example, this JS file is responsible for both users and games, right? So if a bug gets introduced into the user's part of the function, it's more likely that the games part might also break, isn't it? And definitely the complexity part, which we cannot underestimate. So if all application logic is in a single function, the function can get more complicated, and which can slow down your development and makes it easier to introduce bugs, right? So let's understand through this diagram what exactly is a microservice. So here, let's say I have moved this monolithic to a microservice architecture. So here there are two files now. One is a user.js and the games.js. So through this user.js, I can retrieve the user details, I can post user details, and definitely delete the user details. Similarly, for the games.js, I can easily get the games, post any new games, and definitely delete games. So what are the pros of this? See, the advantages of the microservice architecture in serverless inherits advantages of microservices in general. For example, separation of concerns is the biggest factor. So if a bug has been introduced into games.js, calls to user.js should carry on working, right? The user.js will not be affected. Or maybe like if the get user ID, which is you can see in the diagram, right, might contact the game service to get games, then the user plays. But if user.js and game.js are proper microservices, then user.js should handle game.js failing and vice versa. And definitely very less complexity. So let's understand what are nanoservices. Again, this microservice can be break into nanoservices. So here you see, based on this diagram, you can clearly understand this architecture, where I would rather say each and every files, like for get user we have get user.js, for deleting a user we have delete user.js, and for getting a game we have get games.js, and definitely for deleting a game it is delete games.js. So here is the nanoservice architecture over here, which clearly says or identifies that this is being used as function as a service. So each comprises, see, each get user.js, delete user.js, get games.js, and delete games.js comprises each function, right? So each will be loaded into the Lambda service, and each has a specific, very specific role to play. So let's understand the advantage. So nanoservice basically are more advantageous than the microservices, and separation of the concern is greater than the microservices. Very loosely coupled, and if a get user.js has a bug, it is not going to affect your delete user, get games, and delete games and all those things, right? So let's get into the next slide. So we have already discussed the serverless architecture and the nanoservices. So now let's go directly into AWS Lambda. So AWS Lambda is similar to how a platform as a service works. So in a platform as a service, you typically create an application and deploy it into a PaaS. So once deployed, the PaaS manages the operational aspects of the application, including scaling and high availability. So for example, the developer can develop their code, and AWS Lambda will provide you the service as a platform so that you can deploy that code into the AWS Lambda and start executing it. So we have already discussed that microservices, nanoservices architectures have gained popularity, where applications are broken into smaller pieces and much smaller pieces to enable better scalability, more agile development, among other benefits. Lambda embraces this philosophy and allows developer to deploy a single function one at a time. So once deployed, Lambda will manage the operational aspects of that function from scaling to high availability. Just as we have discussed that calculator function, let's say we have four functions out there. One is add, then the other is subtraction, other is divisions, and the other one is multiplications. So each one unit can be considered as a single function which can be deployed in a Lambda as part of a program or a function. So this is why many people use the term function as a service, FaaS, when describing AWS Lambda or serverless architecture. So Lambda has been introduced in 2004 as a service by AWS. So generally the code that you create should not execute more than 5 minutes, but definitely there are constraints on that. It depends upon the memory that we have selected while creating that platform. Small piece of code should be deployed in AWS Lambda, which are small in demand, and it is more of an event-driven applications. Event-driven applications could be like, let's say in a S3 bucket, you upload a photo and you want to create a thumbnail out of the photo, right? So whenever the picture gets updated in S3, so that immediately the event gets triggered and it executes your piece of code. It could be a Java code, it could be a .NET code, Node.js code, it could be Python code, and that code will ensure that the piece of picture that you have uploaded will read that information and create the thumbnail for you and then upload it into the S3 bucket. So as you see that it's a more of an event-driven application, right? So for example, any kind of fine analysis, IoTs, as well as of a backend services. The main supported languages for Lambda on which we will be creating our examples will be Node.js, Python, Java, and C#. So these are the main supported languages that can be built or deployed into AWS Lambda.